going to start because otherwise we won't have enough time for the rest. So, let me go on. For the lecture, change of topics. We're not going to talk about multiprocessing today. We're going to talk about how to build an API and how to then publish it to the web so that you can control maybe your camera or your robot, or just build a simple web page for your system. Bit of admin. First, I publish now the first assignment, which is the description of the second assignment, basically. So you can fill in the details of what you want to do as a project. You have about 14 days to do this, so there's time. And what is needed is covered there, but it's basically really why you're doing it, what the problem you want to solve, what is the state of the art on this, and what are you planning to do and so on. Just keep the overview very much smaller than what you would do for a thesis, of course. It's just a project, but to give us an idea what is the motivation behind and what technology you want to use, and what you want to do with it. They started now, for sure. Yes.
Is there a range for selecting the project?
If you don't have any idea, let's discuss it after the lecture. Right? Range of topic we can choose. So anything that deals with, for example, a piece of hardware, like dealing with the camera and some actuators, or dealing with the multiprocessing system for some reason, a simulation. Anything that you have seen in other classes that you say, I wanted to build a system that solves this problem, or that does this on my own. You can do that. What else? Wise. The project will be due then 1 month later, so at the end of June. And also another piece of admin, I'm not going to be here next week, and neither the week after, but that is holiday on Thursday, so there won't be any lecture. But on next week, you will have a lecture on ROS, Robotic Operating System, from Lucas, who graciously substitutes me, and we'll basically see another way to communicate across networks with different devices. Don't think of anything else. Yeah. And then we'll have a lecture again. We'll start NumPy, and then I'll be again away for a conference for 1 week. So you will have one of our PhD students who's going to give a lecture on simulation, PyBullet. And then I'll come back and we'll finish NumPy, we'll start TensorFlow. So that's basically the plan for the next few weeks. So what is the plan for today is network communication, and we're going to start to see how to organize that. Any questions before we go on about last time, about multiprocessing, threading, or just about the process or the admin? All right. So multiprocessing is one way to solve the problem of dealing with different processes, but it doesn't solve the problem of dealing with different machines, because when they are physically separated, then you need actually to cross the gap between the two machines, and there you have to do networking. We've seen interprocess communication, we still share memory. These are ways to communicate inside the machine itself, right? But if you are dealing with, for example, a computing system, sensors and actuators, like as a typical physical system out there, you will have at least 2 different machines here. Maybe you find something that is all integrated in one piece of hardware. It's really difficult to find something like that. And usually, if you're building it yourself, you're basically relying on several boards which are connected by some network of some kind. We will deal with only the easiest one in this class, but there might be buses, there might be other systems inside that don't rely on Ethernet or TCP/IP, which is what we're going to do. But basically, you will have the same kind of problems. You have to rely on the same kind of architectures, right? Why is communication important? Why are we not just, it's just another piece of code? I mean, we can just organize how we send messages between one and the other. But in the end, if you don't put some thought into it, you're risking building a system that is not scalable. Because when you add a new machine, you didn't think about how this would enhance the complexity, for example, or this will create an exponentially more complex system in the communication between all the machines. Because every piece of equipment you add, you have, of course, n channels more, where n is the number of piece of equipment you have so far, right? And then you add another piece of equipment, is n plus one, and so on, right? And this adds up, right? So it's really complex when you get many machines in one way. So there are different architectures you can solve this. We will not look into topology of networks here. There's that courses for that. I think you can take that, but it's important to understand the problem. Second problem is performance. If you want to do communication between devices and they have to run, for example, in real time, you better be sure that the performance of the communication back and forth, the latency between them is well organized, and you know how to use the protocol and so on. So you want to take a look at that. You want to make sure that your resources are utilized properly, and so it makes sense to look at that aspect too. And then, as we saw in multiprocessing, in shared memory, and in the process communication, in network communication even more so, it's important that the processes happen at the right time and that they're rightly synchronized. Because if you assume that for example, the image that you get from the camera across the network is instantaneously now, but it's not, it has a latency of 1 second, and you assume that the sensor that from the robot, for example, from speed and your actuators are instantaneous with the camera that you feed, that you get, you're going to bump into a wall, because these items are not synchronized. You need to understand what is going on. So the precedence constraints, the timing constraints, these are all things that you need to understand when you're building a network system. And last but not least, you need to be fault tolerant. If one of the pieces of equipment drops out, you shouldn't break the whole system, like we did with processes. If you have a process that you're going, it's going to do something that could turn into an exception, you can monitor it, you can substitute it, you can basically restart it. If you have a piece of equipment that is connected to the network and it stops responding, you have to understand what are your options. Can you make do without that sensors? Can you use other actuators to compensate for it? These are things that, for example, are very important if you do the redundant systems that have to go unattended somewhere and you cannot maintain, right? I mean, until you are in the lab, everything is fine because you can just check, okay, the cable was off. But if it's in space, it's not so easy, right? Anymore. So that's why we look into communication. That's why there are entire courses on this topic, and why we are looking at it today, because it's important for cyber physical systems, particularly if you have high performance computing and you have to, for example, go through a lot of video data to have an intelligent system running a robot. Well, that data has to be with minimal latency on the computing interface, and with minimal latency, you have to actuate based on that data. If it takes 1 minute, then it's not able to drive the robot anymore, unless it's going like, at this very low speed. So we will focus on only HTTP today, which is, any idea? What is HTTP for? HTTP stands for?
No, that's
Hypertext Transfer Protocol, right? This was a very old protocol born in, I think, 65, something like that, I mean, before I was born even. And it's about basically sending over the network pieces of linked text, nothing else, right? But in the end, what hypertext has become is HTML, and it's the same thing, sending HTML or sending JSON or sending XML. And what this has become is basically the backbone on any asynchronous and not, let's say, not critical, real-time critical communication. 90% of the cases you will be good with HTTP. For the rest, you have to dig deep. But for any prototype you might want to build, you start with that, and if that doesn't work, then you actually check, right? if there are alternatives, what the alternatives are. You will see later on at the end of the course, I think, a bit of something about distributed computing, which is not using HTTP. It's a bit more involved in setting up, but there are libraries that do that for you. And we can see how to set up a system that is more optimized than what we'll see today. But usually, this is the easiest route to take if you don't have a timing constraint in the order of the nanosecond. If it's milliseconds, fine. Exactly. I mean, simple setup is supported by a huge amount of libraries, so you can create frameworks for HTTP with whatever language you want, whatever library you want. And in particular, we focus on APIs. So what is an API? What is it useful for? The API is an application programming interface. So it's a set of rules that allows you to control a piece of software or machinery and that are in place and don't change. Why do we do this again? I mean, you could say, why do I have to define an API on one side and separate the system? And I could, in principle, if I had a sensor and a robot and a computing machine, I could consider it a whole unique piece of equipment, piece of software, and develop it as it could be one single piece of code, right? I know there is a network in between, but I can just ad hoc create network calls when I need it, where I need them, right? And that is perfectly fine, unless you're working with somebody else, unless you are intending to work on the system for more than a year, because then it will start becoming a mess, and you will not have the capability to test pieces of software independently of the others, because your network calls are all intermingled from one machine to the other. So if you shut down one machine, you cannot test the other in isolation, right? So what you want to do is to actually modularize your system and decide if this is a camera, right? What can I do with a camera? I can, read the feed from the camera. I can set the parameters like resolution or anything like that. I can, start the acquisition, stop the acquisition, change the brightness. These are the things I can do with the camera. They don't depend on the fact that this camera is on top of a robot that moves, right? I don't care about that. I can set it at the frame per second, so I can set all these things, and I modularize the camera to be a camera and to be independent of my other software. So I can test it in isolation. I know if the feed is working, it's working whether the robot is moving or not. I don't care about the other parts. The same way, if I am testing a processing system that relies on a camera, but I define a fixed API, I don't need the camera to test the computing system. I can take a video of the internet and fake a camera by providing the same API and just pass the video. Then I can test all my software without having the camera online, which is particularly useful because you don't have always access to your hardware when you're programming, or you don't want to have access to your hardware when you're programming. You want to be in the lab all the time when you type your code, for example. The same goes for actuators, right? You can fake actuations. You can just fake having a robot and say, move to that position, and the robot will tell you with a wait of 1 second, moved, I'm done. So you can do all these neat things, and it helps you basically structure your code. It helps you not only test it, but also understand it. Because you're forced to give a goal to each piece of code that you write, right? So this is why we do application programming interfaces. We took the camera as an example. So what is an HTTP API now? So HTTP usually relies on 4 methods, which are, we only see get and post here, but there are also put and delete, which we never use, so we can forget it right away. But basically, we use get when we want to acquire information. That is implicitly known to be able to be cached, right? So when you use post, you do it because you want to provide one-time information, and nobody should cache the response. This is probably an action where you want to change a parameter, where you want to require particular data with particular ID that is known to change. It's not stable, right? But usually it's really to change parameters on your application. So this is the main difference between get and post. We'll see how it's used. whenever you open a browser and you put a web page address, you do a get. That's what you do. And this is the second part of the API is basically the URL, right? We assume there is always one address, which is the server you're calling, the particular machine, the camera, for example. And then you have a URL which tells you which particular part of the application you're talking to and which action you want to do, right? For example, here I want to retrieve the frame, the image from the camera, or I want to change retrieve the status of the camera, which tells me what's going on with, like, for example, if it's on, if it's off, what's the resolution. And then I can here change other settings, right? Question on get post HTTP. I mean, you've seen this before, right? HTTP get post. Okay. So let's think about a robot arm, for example. Now, this is actually pretty close to what we use as a API for our industrial arm in research projects. And it's very simple. We basically have one API to understand the position of the robot. So we ask it, where is your wrist? We don't care where's the elbow because that doesn't bother us, but we want to know where the gripper is, right? Because there's a camera attached to the gripper, so we want to know what's the point of view of the camera. That's why we have this API that tells us what is the position in X, Y, Z, and the orientation with the other angle of the camera itself, or the wrist itself. So that would be a get. And then we have one API, well, one endpoint in the API to set target position. So if we want the robot to grasp this object, we compute where the gripper must be, and then we tell the robot this is the target. Then we have two different endpoints to start and stop the motion. So this basically starts an internal program in the robot that checks this variable that is set by this other endpoint. There's a registry that we set with this endpoint, and the other program basically looks into this registry and then moves the robot until it reaches that position. Then it looks back in the registry, and if there is an updated position, it moves to the new updated position, and so on. Unless in the meantime we call the stop motion, and then it checks in the stop motion registry, and if that is flagged, then it stops moving, right? So this is a very simple application, very simple API, but we do publish research in robotics with this, right? So no, we don't need fancy stuff. We can use it with just a simple HTTP API. So how do you build an API? Well, okay, you need to know what you're doing. So first you have to identify your use case and list your functionalities. That's basically your endpoints, right? What you want to do with your machinery. Check the frames, set the resolution, activate the motion. These are your functionalities. And therefore, then you define your endpoint. Once you have defined your endpoints, then you want to structure them, right? So, but before you do that, you can choose your right framework. Now, we'll see only one. We see Flask, which is one of the easiest one. But last year I took Django, which is a bit more involved, and also something that relates to my experience because I built applications with Django for a decade, and other Node.js, in Java, whoever uses still Java. But there's many opportunities to build APIs. We'll use Flask. But then again, you might actually want to use something different because maybe you will use Python because many of the things we do are related to Python because it's like performance computing. There's NumPy, there's TensorFlow, and so on. But if you're using, for example, something that is very low level and you need to use C all the time, you might actually look for something that is built in C++, for example, right? So these are considerations you want to do. But done this and chosen a framework, then you have to design the API. Design actually how you want to implement this functionality. And there are several things that you want to keep in mind. The first one is that it should adhere to RESTful principles. And we'll talk about that later, what RESTful principle is. Second one is that you should use the right get and post, or put and delete if you really need them. Get and post for accessing your functionality, right? And you don't put, for example, a parameter change into a get request, right? So that maybe some machinery in between caches that get request and it never arrives to the robot itself. And then once you've done all this, then it's basically naming. Like, how do I group my APIs according to what name, how do I set the actions and so on. I mean, this is just basically for you to easily understand it. So what are RESTful principles? You haven't heard about this? RESTful principles, REST in general? No? All right, so RESTful principles are basically an architectural style. It's not even an architecture. That was defined, introduced by Roy Fielding a few years ago, many years ago, about how to build something that is solid and modular. It doesn't need a lot of debugging in the long run, right? And I think the most important one, really, I would say is the second, but it's so obvious that you don't really think about it. So it's the first. The first principle that I have there is statelessness, which means that if I tell my robot to move to a target, that command does not require the robot to know, for example, what was the previous target that I set. So if I give it, for example, an absolute target, right? The robot, given that particular target, can move directly, doesn't need anything else. But if, for example, I give it the X in one call, and the Y in the second call, and the Z in the third call, and so on and so forth, right? Then it really needs to know the history of all my calls. Cannot operate on a single call and have all the data and all the information that it needs to operate on the position itself. And that means that it's not stateless anymore. It needs to keep a state. It needs to keep a memory of what commands I said before. Now, why do I want to do this? A stateless system is more robust. Because if I miss one call, nothing is going to happen, yes, but I don't have a corrupt system. If I'm missing a call, if I'm missing the last angle, for example, right, in the position, the orientation of the gripper, and I miss it, and the robot on the other side is still waiting for this last call, and then I start giving a new target, so I gave X, Y, Z, and so on, and I arrive to the last angle again, it is ignoring all my other parameters until it got the angle. It gets the angle, now it's in the previous position with 2 rotations right, but the third rotation completely off, because it's basically a random parameters put together from 2 different calls. So this means if you have a stateful system, you run into all these sort of bugs whenever you have a communication interruption. If you have a stateless system, the most you can happen is that the robot doesn't move to some intermediate step. It's just jumping one. One call has been dropped, you don't have a corrupt system. It still goes on, right? Client-server architecture means really that if you define an API on one side, and you have basically, let's make the example of the camera. You have your computing algorithm that feeds on the video from the camera. So you want the camera to be the server and feed whatever data it's requested to, and the computing infrastructure to be the client to request data, right? Or you want to do the other way around. It's your choice. If you want to the camera to push data into the algorithm, right? And the algorithm just to respond with whatever the camera decides. But you shouldn't do both. I mean, you shouldn't act two flow of programming controlling each other in a crossed way, because then you don't have a single point of control flow for the program. So you want one piece of hardware to be in charge and the other one to be reactive. And that's what client-server architecture means. By organizing your code like that, you put your logic into it, for example, the computing unit. They use the camera and the robot and so on as reactive machines. They do what I tell them to do. They provide me the data I want to, but I don't put logic in there, right? So that's the other part. Cacheable. Yeah, I mean, this is not really so relevant for cyber-physical system, but many times it's very useful because sometimes you have huge data and you're requesting the same data again and again and again and again and again. And there's a whole classes on this topic. A uniform interface methods, I mean, we just spoke about it, and layer system. A layer system is quite interesting because sometimes, you know, the camera is a very complex machinery, for example, but to you, it's just something that feeds frames. right? So you don't care about the rest. What you want to, if you were building a camera, not a system built on top of the camera, you might think about, okay, my software that goes inside actually needs to communicate with each other. There's this another network inside, but I don't care to expose this to the external API. So I have one API reaching the camera, then maybe other APIs inside. Again, for your computing system, it might have a distributed set of servers that actually run the computing for you, and they have an API in between. But when I access it from the outside to know what the answer is, I don't need to expose the APIs to the distributed computing machinery behind and so on. So this helps also layer the complexity as well as the access points to what you're really concerned at this level, right? And finally, the topic of the day, Flask. Flask is a very simple, very lightweight system, we'll see. It takes 4 lines to build an app. It's modular. You can build reusable compute components. We won't see any of that today. There's a huge community and support, and it's in Python, which means that it's perfect for us because we use Python for everything else. So this is a Flask app with everything that you need. So there's nothing else. There's no other configuration file. No, I mean, if you use anything like Django or other platform in Java or anything else, you know that you need to build like a tree structure with all the configuration files and templates and everything. That's a full app, right? 4 lines of code, you get everything. What it does is pretty simple. I mean, we import Flask, pretty clear. Then we create an app, which is a framework for everything else. We tell the app that the next function is what we want to answer when somebody calls the slash, the root of the URL, right? And in the function, we just return what we want to return, right? Easy as that. And then we run it. You see this already, if name main. You remember what that is?
If we have this, we can do some from this.
So this one is to check if this script was started by you or was started by some other internal Python scheduler through multiprocessing or other systems, right? Because if it's started in another way, for example, for an import or from other in other ways, but not directly from you from the console, then name will not be set to main, but to the name of the script minus pi, right? So in this way, you make sure that this is not started many times. And why it is like that? Well, because otherwise Flask will start the script again to check if something has been changed and refresh its mapping, internal mapping, so that it can answer with the new code. But by doing this, you will start the second application again, and so on, and so on, and so on. And so on. So that's why the if name main. This is something that we've done in multiprocessing most of the time, right? So, going back and forth here, let's actually look at this one as an example. This is exactly the same code. So there we go. And when you run it, well, it doesn't print anything because it's actually a web app, right? So we have actually access to the web. And here it is. And what a surprise, it prints hello world, nothing else. But hey, we built one web page with 4 lines of code. So let's see what else we can do with this. I mean, this was pretty boring application, right? There's no style, no colors, nothing, it's just some text. But it's easy to do. Have you ever seen HTML inside? Have you ever worked with HTML? No? Okay, so it's not really hard. There's basically a bit of structure. There's hello, okay. Now I did it. Come on. Sorry. It's my boomer moment. Okay. So basically you have well, it's a tree structure. It starts with the HTML and ends with the HTML. And inside you have other tags that define regions of this document. The head here defines, where's the head? Geez, I forgot the head. Okay, there should be a head here, open. For some reason I forgot it. And it didn't tell me it didn't run. Okay, and it closes here, and you can just write some metadata inside, for example. By writing title hello, this hello will be printed on top of your window, not inside the page, but on top of the browser window, right? And you can put other things, like you can link JavaScript code from here, you can link style sheets from here. It's all in, goes all in the head. And then there's the body. The body is actually what gets printed. And it's pretty, I mean, the basic structure of HTML is pretty simple. These are headers, H1 to H6. You can basically build larger or smaller text with headers. And then you have stuff like P, which is a paragraph. You can put text inside. And this is if you want to be nice, otherwise you could just put text inside without an P and just have, so one space or 15 space is the same. One space or one new line is the same. It's just one space. If you want a new line, you put BR, break. That's it. So, and the rest just get put together. So you don't have to care about formatting, because the formatting will be done by the HTML reader, by the browser. You can put one word per line if you want. So if you have a program that spits out, text, but doesn't format them well, you don't care. Just put it together later. The important part is that if you want to break, you need to use BR, and otherwise you need to use paragraphs to separate paragraphs, right? And then there is a lot more. You can put tables, you can put images. Images is just the IMG. It's just type like this, IMG, and then you give it a source. SRC will see that actually later, and that's it. And that prints an image inside, right? So it's very convenient to build quickly an interface to do anything. And this is actually might change from the previous code, which was return hello world. Now it does return render template. Template HTML, which is where it's found, and name word, which is the variable. And why does it need a variable? Well, because here there's something strange. This is not HTML. This is actually what is called templating language for Jinja. Jinja is a templating environment. So what you do here, and there's much more also to Jinja, to templates, we won't go into it. You can do if, you can go do force, you can do a lot of other stuff. But for now, I mean, just to see an example, with double curly brackets, you can put a variable value inside your HTML, right? So you can render dynamic content without spitting all the HTML from code, which is boring because you have to create a string and put everything inside the string. You can instead rely on the template and edit it with any HTML editor you want. There are actually visual HTML editors now, like Word. You can actually build it like, put the paragraphs here and so on and spit the code later. And then you go inside and you put the double curly brackets where you want them. And then you can feed inside, a table, the values that come from the code. So that's why it's used. That's called a template. And you use it like this, just by calling render templates, passing the template and passing all the variables. Now we're passing only one, but you can pass a lot more, right? So again, quick check. Let's remove this. If we go to, this is not the right one. Many windows open. Okay, they close it. No, it's it. So, full screen, so I full template. There we go. So, that is our template HTML, and we can run it. Oh, wait a second. First stop the other one, otherwise I have to change port. Stop this one too. And let's call it. So now it's bigger, but you can actually do a lot more interesting stuff with this. You can, for example, do something like this, style, color, let's say red. or blinking or something like that. That was very famous in the 80s, 90s, 80s. There was many in the 90s. So and let's stop and run it. There we go. So I called this second. What's going on here? Current file. I run the template. Very smart. Let's run the code. How about that? There you go. So I mean, you can basically design your interface in that file and then design the functionality in a separate file, right? That's the whole story about HTML and templates. Routing. Flask has this very convenient way to do all the writing. Basically, once you have instantiated your app, you remember you instantiate the app by calling Flask and basically assigning this to an app. This is that app, right? And then you can use a decorator from the app, which is route, or you can directly use get and post if you want to separate which function should respond to a get, which function to respond to a post, which is very convenient. Then you can just pass the URL, and then you have, for example, here the one returning always word, hello word, and the other one that is actually looking at what name you provided. Right? This is a magic variable here that's there for you when you are inside here. It's defined by app basically, by the decorator. You remember how a decorator works, right? They are wrapper for functions. So I can define some variables in there, and they are in your scope now. So I define this variable request in the decorator so that the update name has access to request. And from request, you can get form, get the name that was in that form, and if it's word, we'll print hello word in there. If it's not, sorry, if it's none, we will put word. Otherwise, we'll say hello whatever was in there, right? Is this clear how it works? Okay. So just let's look at the old code, which is there. Let's remove this. Right. So the rest doesn't change. The only thing that changed, let's move this back. The only thing that changes that I'm using these different decorators for get and post, and that I am actually using request form get to get the parameter that was passed. Now this is very important because if you build in an API and you're passing some parameters like change the camera resolution, then you do exactly something like this. If we run it and we don't forget to stop the other one. Then you can take your typical Alice, hello Alice, and so on. Okay. So now you have gone for a step. You have an instrument to feed data into your API, and you have something that returns data from the API. Now, of course, this is a web page, it's not an API. So how do we go from this to API? We use JSON. I mean, we could use any other language. We could use XML. We could use, I don't know, just a string with all the parameters mangled together, and that you only know where one ends, where the other begins. And you can do anything you want, but JSON is a standard, and it's not a standard by chance. It's standard because it's easy, it's readable, and it's compact. XML is also readable, but XML tends to be very wordy. So if you take the same data and you package it in XML, XML is basically HTML with free way to define tags. Okay? So you can define like table data, row data, column data, my field, put the number here, close my field, close column data, close row data, close table. That would be an XML. I can define the structure of the XML that I want. JSON is different. JSON is structured as a JavaScript array or a JavaScript dictionary, right? It's exactly the same syntax. And it's very easy to build in Python as well because it has so many tools. We saw them in one of the lectures to actually build JSON from a Python a dictionary or a Python array, or convert back a JSON to a structure in Python. Right? And Flask is even more easier than that because it has this very fancy name JSONify command. Basically, when you want to send a response which is JSON, you just put your array inside the JSONify and return that. So it's quite easy to use. And when you build the JSON API, you build your data endpoints returning JSON data, but also accepting JSON data. So you don't want to use the parameters unless you have just 1 or 2 parameters. But if you want to communicate data, you basically create a JSON file package, as you want to call it, and you send it as one single parameter. Then you basically have the code in Python unwrap the JSON and pick the parameters where they are as it needs to, right? And yeah, so then you use, of course, get, post, and put and delete if you need, and the HTTP status code. You know what HTTP status code are? 200, 300, ever seen? 404? What is 404? Not authorized, right? What is 200? All good. So basically, the basic idea of the parameters are 200 is good, 500 is bad. Everything in between is a range of, okay? So 300 is usually, it's redirected, for example. I don't remember which one exactly, but redirected code, if the changes, the server wants you to call another URL, which is usually then handled directly by the client, by your browser, it sends it 3 or something back. The client sees the 3 or something, reads the URL, calls the new URL. So it's temporarily unavailable or moved. That's a 300. 200 means everything is successful. I never seen anything beside plain 200. I don't know. I should look if there are any other codes. 400 is usually not authorized, or you're not allowed to do this, or this resource doesn't exist for you, or indeterminate, in a non finite way, not temporarily, so not moved, it just doesn't exist, or not accessible. But the server works. That is a 400. 500 means the server crashed. Internal error, something really bad happened. Programmer died. All this gets one of the stories. Okay, so 400 is bad, 200 is good. That's all you need to remember. Exactly. 404 is not found. Yeah, not authorized. So, so when you build the APIs, just don't rely on JSON. If you're sending an error, send also the correct status code. If you want to put data, use the correct HTTP method. Don't use GET. Okay. So just a reminder that JSON is not the only thing that you are using here. You're using also the rest of the infrastructure that we built. JSON API example. It's not so much different than what we had before. So we had the same app route, and in this case it's not slash because I wanted to show you something different. And you can call it also, instead of app post, you can use methods post. So you can put more methods there. Like it responds to get, post, but not put and delete, because who used them anyway? Or you can put just one here, and because you didn't like the app post system. Anyway, you can then describe all the code here that you need, for the particular post message. And what you do is really simple here, right? Post hello. This is basically to ask you what name you want printed next to hello, right? And what you do is you get your data, request get JSON. Pretty simple. It's supported directly from Flask. You see, you don't have to first get the data out and pass it to the JSON library to parse. You just integrate it directly in Flask. You get the name by actually looking into the data. It's a dictionary now, and getting name, and if there's nothing, you return word. So this name is always defined, and then you return another JSON, this time by using JSONify and putting here the dictionary inside. Right? Very easy. Right? So this way you build a two-way API. You can, on one side, provide API by providing the message. On the other side, write JSON by putting JSON in the message. But on the other side, you can get data from a JSON file that was sent to you. Okay, and so if you want to test it, this is something that we could do, for example, because you cannot test this on the browser. I mean, there are also tools that you can use to test APIs that can make you select which methods you want to use, or and put all the parameters and so on. You cannot actually put it in URL in the browser because that's always a get. You will not be able to generate a post. You have to do it with HTML with one of those tools, or with car, if you know car, or wget on the command line. But this is about what you can do. So, but we can do it in Python. We have Python, why not use Python, right? HTTPX is another library, one of the many. Requests is another that we use. HTTPX is new, but it's quite simple for this. You can just use HTTPX post, put the URL, and put the JSON inside here as name Alex, and then print the response, response.json. It's also support JSON very well, HTTPX. And this will give you what? Well, we expect hello Alice, right? If we do this. So let's move and test it and look at a bit more details. There. So there's a bit more code, of course, because there's some housekeeping to do, but let's walk through this. Okay. I mean, simple imports, HTTPX from Flask. I need a few more things. I import multiprocessing because I want to start the testing on the same, script that I'm here, and not start the script separately. Just a gimmick, just because we did multiprocessing already, so why not? And then I have my get hello, my post hello. So get hello is just dumb. It doesn't take anything, and it always prints hello world. Easy. But the post hello, it does exactly what we said before. So in the testing function, I sleep 2 seconds just to give a chance for the old machinery to start, right? Then I collect the response. I assert that the code is 200, and then I print the response, right? It's clear, right? It's what we just talked about. Then I start my multiprocessing, and I tell it not to reload. Because if I allow it to reload, it actually will execute the 2 times my multiprocessing start. For some reasons, I didn't understand actually. But if you remove the reloader, then you can actually start it 2 times. I mean, this is something you would never do in a real system. You would not start this together with the app for Flask and another process in the same line of code. But anyway, it was just for testing. So if we run it, well, we wait a bit, and then we have an assertion error because something happened. Because it didn't find. That's interesting. So, okay. Let's invert this. Port already in use. It was easy. Forgot to stop the other one. Right, so what happened here? We started the server. It started its endpoints on localhost 5000. And then we called localhost with name Alice. We provided the name in the JSON payload that we gave, and it answered with this JSON string, which is what we expected, right? It's clear what's going on and how. Okay. So let's talk about authentication for a second. No, actually, before doing that, let's look at another example. It's a bit more interesting. Since we have the time. Right, let's stop this one. And let's run this one. All right. So now, all right. So this is a different application. And let's walk through it before we actually do the demo itself. So what I'm doing here is I'm trying to use my camera to see how we can actually set up a system that does a bit more, or more something like sensor reading. I'm using OpenCV to do this. We'll see more and more examples with OpenCV. OpenCV is a library for computer vision. You're familiar with it? Okay, so in this case, I just use it to read the camera and to get the frame from it, right? And also communicate to the camera, like parameters for running in different scenarios. So in particular here, I'm starting a video capture. This is just a parameter to tell it which device to use. 0 is usually the built-in camera if you have a laptop, but if you have multiple USB cameras, it might be 0, 1, or 2. You have to test it. Depends on how it's connected to the bus internal. Right, then I have a landing page. It's usually a good idea if you're building an API to actually have a piece of HTML and functionality that lets you test the API, right? So instead of actually writing, on the command line scripts to test each endpoint, you can use the HTML and a button to test it again and again whenever you want. So this random index HTML, we'll see how it is built. And then we have a route for API camera frame, which is a get, and which will actually return a image. Now, sorry. First of all, a couple of housekeeping here. The camera read will return a success and a frame. If the success is not true, then we actually have to inform our client that this failed, and we have to return an error. So in this case, we're not returning the frame, we're returning the JSON with the reason for the error, and important, bad code, right? 500, internal error. Then, if everything goes well, so we are not inside the ZIF, we go here, we encode the frame to JPEG. There's basically a standard piece of code. Yeah, you have to see it in the CV2 in the OpenCV documentation. We transform this buffer then to bytes, and we return it as frame. The return was just here. Just tell it, give it the bytes, and give it what type it is. Meta type, MIME type. You ever heard the MIME type? So MIME type is a set of strings that define the content of whatever answer you're sending over the network. So this could be, for example, text, simple text HTML, and so on. What can be image JPEG, image PNG, or application binary. These are all different standardized pieces of string that are instantaneously recognized by other softwares and identify what is the payload that you gave it, right? So it's metadata about the payload. It's always good to send the metadata with the payload. Sometimes the client will be able to decode the fact that this is a JPEG automatically, but it's much more, nice. It's much nicer to tell it what kind of image you send so that you can take the right decoder to start with, right? So far we have the landing page and the way to return the image. Now let's scroll up. Not from here. Jesus Christ. From here. And let's look at API parameters. So here, what I want to do is something different. I want to be able to change the setup of the camera, right? So I open up an endpoint where just a simple example, change the resolution of the camera. So I want to tell it what resolution I want the imaging, right? Or what resolution should the camera use for its internal operation. I don't know how it's used, it's the camera, and then we'll use this operation. So what I'm doing is, I'm using the OpenCV API, right? That hides from me the complexity of the camera. So again, layered, right? I'm exposing this part of the OpenCV API through a wrapper that simplifies the setup for my user, but internally I'm using the OpenCV API. What the OpenCV API does with the MacBook Pro camera, I don't know. Okay, but I'm passing this through. Then I'm just printing it for fun, and then I return a message that that was successful. Why did this pop up? I don't know. Right, so nothing else. If name true, uprun. So let's start it. We already started it actually. So it's right here without the red lines. I mean, we didn't put much style in writing it, and it's very ugly, but it will work. For example, now that's my face. So let's actually do it like this. I'm going to have to stare at my face. There we go. And let's try to change the resolution. Let's try 720p, which is 280 times 720. Set parameters. Get frame. Smaller. Let's see in the prints. Did it print anything? Oh yes, 128, 720. So now let's try something else. Let's try 640 was proposing that times 480. Set parameters, get frame. Worked very well. Let's try something completely different. For example, how about 144p, 44 times, I don't know, 480. Now it's going 1920 times 1080. It's going full HD. You have an idea what's going on? I told it to go 1440 times 480, and it went 1920 times 1080. So not even close. I mean, it's not even one parameter is the same. I cannot zoom this in. Yes, I can. Sorry. But 640 times 480 worked. 1280 times 720 worked. This did not. Nicola? Was something wrong with my code? What do you think? Something wrong with the camera? So the first question is, the answer to the question is something wrong with my code is always yes. It's just a question of what degree of wrongness. That is always, you learn it's always wrong, something wrong. There's always something wrong, something to debug. But in this case, I'm not at fault here. I send it the right parameters, it just refused to do it. Why? I don't know, and I can never know. I mean, it's in the firmware of the hardware, right? So the fact that we have layered APIs, it means also that we're not in control of every step. So what we're really using here is set parameters, more a suggest parameter. Try if you're able to, but you might not. And this is a safe design. What Apple is doing is not just saying breaking and throwing an exception and saying, you don't get anything and the program crashes. No, sending you an image, sending the image that, according to my short debugging, contains at least a resolution wide enough and tall enough to fill in your request. Like if you want 1440 wide, well, that is more than 720p, so it needs to go full HD, right? But if it doesn't have that form factor, it will tell you, the greatest form factor that can fit in your request inside. You'll have to deal with it. But it sends you something back, right? So it's fault tolerant, as we saw in the beginning, and at the same time, it's modular, which means you're not in control of everything. So, should we see quickly the template? Nothing much there, but it gives you an idea, since you've never seen HTML before, gives you an idea how slightly more complex HTML works. And if you want in the future to build an interface for your devices, then this might come in handy. So, all right. So what's going on here? Head, this time properly open and closed. And here you see style, which is basically where you define what should be the way that the stuff is put on the screen. So in this case, it's referring to an ID or a class. What was it? Image ID camera, exactly. This is an ID. The class would be with the dot. So if you're referring to an ID, you're basically singling out the element that has the same ID camera, and you're telling it to please put the stuff inside the style attribute. The style attribute will then control the max width to be 100% of the screen. So even if the image is greater than the screen, it will squeeze it to 50. And to make the height auto adjusting, so that since the width is set, the max width, not the width, the height is auto adjusted. So what happens is that if the image is smaller, it will just fit in to its proper scale. But if it's larger than the screen, then it will the height will auto adjust, but the width will be blocked at the screen. Well, then the style is loose. By the way, there's some more meta information. This is not really so important that we need to spend time on it. H1 header, so the big the big header up here, it's compared to small text down here, right? This is why it's bigger, because it's in an H1. Break line, button to get the frame. Oh, in between there is an image, sorry. The image with the camera, the break line, so that the text is not next to the image, because if you don't put the break line, the text will be to the right of the screen. You never see it, and you think, my app doesn't work. No, it does work. It's just printers off the screen. So put a break line. There are better ways. You can do layouts with tables or with even divs and so on. But it's all advanced stuff. For just a simple interface, break line will do. Break line, a button to get the new frame. On click, get frame. So now this get frame is a JavaScript function. We'll see it later. And a label. What's written on the button. It's really simple as well. Another break line, a form. A form is something where you put data that goes to the server, right? So in here you want to put the resolution you want. You have an input text for this, and you have a button to send everything. On click, set parameters. Set parameters is another function. It's another JavaScript function, right? And that ends the form, and now we have the script itself. So get frame, set parameters are the two functions that we call. Not that difficult. So get frame uses this API basically to fetch this particular URL, and then send this basically. Let me see, create object URL, get element by ID, source URL, exactly. So it takes this this element and it creates with it a URL, and it sets it into the element that it gets by ID as camera, right? So there's several passages here. First of all, I want to basically update the image. To update the image, one simple trick to do is just to update the source. Whenever I update the source, the browser will actually refresh the image itself, because it will call the source, even if the source is the same as before. Right? Usually it does that. So what I'm doing is I'm taking this object from the document. This is on the document. Document is something that you get for free. Document get element by ID is a very famous JavaScript function. on document that will tell you will give you the object that represents this camera ID, right? Which is the image tag that we saw before. And then I set the source to this URL. URL is this constant that I have created by looking into this endpoint, and from this endpoint creating the blob, which is a large binary object, and retrieving from it the full URL that I need. Does it make sense? It's a bit convoluted. And basically what it's doing is just looking into a piece of my API, taking the full URL and passing it back into the system, right? And then there's some error handling. So in set parameters, it's basically posting the data that we had in the form to my application, nothing else. So getting the resolution, again, get element by ID from resolution, value. Split X, it basically separates the 640 from 480. Then it creates an array, a dictionary, and some let's say checks that is built correctly. So if its length is 2, then it basically creates a resolution array with the X and the width and the height, right? Resolution 0, resolution Y. Then it goes on and calls API camera parameters with method post and again meta type. What I'm sending to you, application JSON. And then as body, it takes the data that we created up here, right? And it uses the equivalent of our JSON Python library, which is the JavaScript equivalent, that basically creates from the variable a string that I can pass now to my API. So now I'm calling the server because this runs on the browser. The browser could be another computer, it doesn't have to be the same computer, right? So all this is running there, but these calls, fetch and the one above here, they call the server with this content and then retrieve the content, the results. In this case, the only thing that I want to know is that the data is being saved correctly, so I don't do anything with it. The other case, I was actually checking the data, the image that I received, and putting the URL of it inside the browser. But in this case, I just checked that the data was saved correctly, and that's it. So console log on data in error, console error. So that's the script. That's that's the HTML. Now, I haven't gone into any, and I will not go into any of this for real. There are frameworks to do this that build nicer interface with buttons that look actually nice and aligned and so on and so forth. And they have all this machinery for asynchronous communication from the browser to the backend, organized in proper structures. It's just you could do a whole class on it. So I will not do anything on this. But if you want to do some web interface in your experiments or in future in your works, then it's helpful to see how you can build the very basic one, and how you can fetch data and send data back. Any questions on this? So, last thing I want to do is authentication. So, not everybody should be able to activate your robot, right? You want to be pretty sure that if your robot is in your room and you're doing the demo, somebody else doesn't actually log into the robot and does something stupid and jumps out the window, for example, or hits somebody or damages some equipment. So that's why it's usually a good idea to stay careful. And whenever you are doing some actuation, even reading, but definitely when you do some actuation where you're changing parameters, when you're deleting data, put it behind an authentication, right? So how does authentication work usually? This is a simple example that's done with Flask and token infrastructure. You basically have a challenge. In this case, it's a username password, but it could be a private key, it could be anything. A challenge is something where as a client, I provide some data to the server. The server authenticates this data if it's actually valid or not, username and password, they match are in my database and so on. And if they're valid, then I produce a token, which is a long string, which I give you back to you and tell you for the next 1 hour, whenever you want to do something, just return to me this token. And with that token, you are able to do stuff on the server without going through the verification again. The verification might actually be more involved than the token verification. So now when you want to do communication or read the data, change the actuators and so on, just use a token and then you do it. And what you're doing on the server side to verify that all this is done properly, well, there's two things. To verify the token, you use this out verify token, the decorator, and it tells you that this function basically does the verification. So whatever you put in here, it will execute and will give it true or false, and that's it. The server will trust you on that. So you can do whatever verification of the token you want. Let's say you don't need username and password. So you have a single secret, which is saved, stored carefully, and only given to other machines, and nobody knows it. Then you can just skip all this and say if token equal to hard-coded, and that's it. Right? But if you want to implement username and password, you can go through a bit more interesting stuff. In this case, check if the username is there in my tokens. If the token is there and if both are matched, then I return the data for the user, right? So when you want to protect something, Flask gives you this capability to set it behind a login requirement. So what it means is that to access this function, however routed it is, if it's going through this code, this will check if you're authenticated, if you have the right token and so on, right? So you send the token together with your request, and you don't care about what's happening with the token. You just put the extra decorator. This is why decorators are so convenient, right? I mean, your functionality here is just the functionality that you wrote so far without any changes. You don't have to care about it. You just add this extra piece of functionality. At some point in the past, it was a fancy word. This was called aspect-oriented programming. And these were called cross-cutting concerns, which in some ways is a very good way of defining it. Authentication is a cross-cutting concern. It doesn't have anything to do with your functionality. You use it everywhere. It's transversal. So you don't want to mingle it with your own code. You want to separate it and use it as here, for example, with an authenticator, or with a scheduler, a routing system where the authentication is kept and managed somewhere else, so that you don't have anything of this here. This is a choice. Flask chooses to be lean, to not have configuration files. So everything that you do is in your code. You have the decorators for this. You want to put the routing, you want to put the authentication here. Is it clear, that part? So let's see it in action. Just making sure we don't go over time. And there we go. So this is a bit more code than before, but all right, a bit of imports. In particular, Flask HTTP P out, right? HTTP out, and verify token and login, as we said before, and the secure data. Now, what we didn't talk about is generate token, which is used here, right? So what's happening in the login is that we check the username, we check the password, and then we check if username in user and password for that user is password, then we generate the token, right? And we return it as a JSON. This token itself is generated here. It's generated using JWT, which is a standard library for tokens for authorization. What we do is we save it internally, important, because if you don't save it, you can't use it later for authenticating the same client, right? So you save it and return it. And you set an expiration date and everything else. I mean, this is carnage of code here. So once you have logged in, you save the token, and or otherwise you send another 400 valid credentials. Then the next step is automatically done by verify token. Verify token decodes data, gets the secret key, and if the data, if the username is in tokens, and tokens data username is equal to token, then you're done. The only thing it needs to know is the token, because the token is already connected to a user, right? So it just needs the token itself, and it's all the data it needs, completely stateless again, right? The only thing is that it remembers one thing, only one thing, that you have been authenticated once, and that's an expiry date. Otherwise, it sends you some exceptions and return none in the end. That's pretty much it. So one thing I want to do is to actually run this, but to test it, we'll do something a little bit different, and because I want to show you how to use command line for this. So we'll test it with a command line setup, for which I need to do this, because I don't want to copy the commands or do them again. So here we go. Do this now. No, I'll zoom in. No, cannot zoom in. Okay, I'll do something a little bit different. We'll do it like this. So the first command that we're going to use, you're going to use curl. Curl is a command line browser, and it's very useful when you want to quickly test your APIs. You don't want to build a mask, or you don't have a specific GUI for testing. So what you can do with curl is download web pages, set calls on to some web address, whatever you want. You can select the method. You can select what you want to hand over, and the payload basically. So in this case, I'm setting the content to application JSON, and I'm passing username, password to this particular URL, right? If you want to learn how to use it, you have to learn all this -d, -h, and so on. But basically, you can check on the internet how do I curl a post, and or ask ChatGPT will give you the right answer. You can just test it. Or if you want to go the right way, you can read the documentation. But this is what it's going to do. So if I start this, what I get is, I'm going to copy it over so you can see it in all its beauty. So we get this token. This is a JSON that we got in an answer, and this is the token, which is pretty long. It's good because then nobody's going to falsify. So copy this token. This is what your code should do then, right? Not you by hand. But once you receive the token, you save it on the client side. And the next thing that you do is you do a get for your data, and you copy in the token. Oops, but not here. Oh, come on. That was stupid. So you copy it in the command inside the authentication part, so that you can get the data. We can test it with curl, but we need to go back to the right position and delete all this. Sorry. All right, so let's copy it over. So this is the final code then, curl -x get in this case, I give it the authorization bearer token, and I just get the secure data endpoint. Up here I was getting the, I can find it, I was getting the login endpoint, right? Now I'm logged in, so I get in the secure data endpoint, but I'm passing it the token. If I do that, hopefully I didn't copy it wrong. Unauthorized access. Okay, I used the wrong token, guys. I'm not gonna copy it again, but basically you can, if you copy the token inside, then you can get the secure data from the server. Problem is I pressed down button instead of enter, so I deleted my copy paste. Anyway, that's pretty much it. We have 5 minutes, so if there is any questions, otherwise we can close it here. Good. Then I'll see you in 3 weeks. 3 weeks. Next week you will have Lucas with Ross. It's going to be very interesting. He's an expert. He's using it all the time. So, and the week after is holiday. And then we start NumPy. We get into the interesting part of the class. Okay. Thanks.